So we're going to take a look at this question from the 2013 Leaving Cert Higher Level Paper 1. It's question 6 and it involves trigonometric functions, finding the area using the trapezoidal rule, finding the area using integration, and calculating percentage error. So the diagram shows the graph of the function y equals sine x in the domain 0 less than or equal to x less than or equal to pi, where x is a real number. So we can see the domain here from 0 to pi, and we're asked to complete this table correct to 3 decimal places. So we're looking for y values for various x values in the domain from 0 to pi. We can see that the step in the x values is pi over 6, and the x values are in radian measure. So one at a time, we're going to sub these values of x into the function y equals sine x and get our values for y in each case. To keep it organized, we're going to use an input-output table to calculate the values. So on the left-hand side, I have all the x values that I'm going to sub into the function. I have my function in the middle, and then the y values that come out. So when x is equal to 0, well, y is equal to the sine of 0, which is 0. And we can see that from the graph. When x is 0, y is 0. And so we add that to our table. When x is equal to pi over 6, y is equal to the sine of pi over 6, which is equal to a half, and we add that to our table. And as I add them to the table, I'm just making sure that they're in decimals. When x equals pi over 3, y is sine of pi over 3, which is equal to root 3 over 2. And root 3 over 2 to 3 decimal places is 0.866. When x is pi over 2, y is the sine of pi over 2, which is 1. When x is 2 pi over 3, y is the sine of 2 pi over 3, which is root 3 over 2, which again is the decimal 0.866. When x is equal to 5 pi over 6, y is equal to the sine of 5 pi over 6, which is equal to a half, or 0.5. And finally, when x is equal to pi, y is equal to the sine of pi, which is 0. And again, we can see at the end, when x is equal to pi, y is equal to 0, which is our final y value for the table. The B part then asks us to use the trapezoidal rule to find an approximate area of the region enclosed between the curve and the x-axis in the given domain. So the trapezoidal rule is in our tables, and a useful way to remember it is that the estimated area will be equal to h over 2 on the first plus the last plus 2 times the sum of the rest, where h is the interval size, in this case the step between the x values, pi over 6. For the first, we're looking for the first height, and in this graph the curve starts on the x-axis, and so the height is 0. Similarly, for the last, the curve ends on the x-axis, and so the last height is also 0. The sum of the rest of the heights, well, they're going to be our y values that we calculated in the A part. So a half, root 3 over 2, 1, root 3 over 2, and a half. We could use the decimals above, but just for greater accuracy, we're going to use the surd form that we have here for now. So subbing those values in, we have A is equal to the interval pi over 6 over 2 on the first height, which is 0, plus the last height, which is 0, plus 2 times the sum of the rest of the heights. A half plus root 3 over 2 plus 1 plus root 3 over 2 plus a half. Pi over 6 divided by 2 is pi over 12. 0 plus 0 is 0, plus 2 times the sum of the rest of the heights will be 2 plus root 3. If we multiply 2 by 2 plus root 3, we get 4 plus 2 root 3. So we'll throw this into the calculator to give an estimated region for the area between the curve and the x-axis as 1.95407 units squared. Part C asks us to use integration to find the actual area of the region shown. In the previous part, we used the trapezoidal rule to estimate the area, but the trapezoidal rule is only ever an estimation. The trapezoidal rule has split this shape into 6 trapezoids, but it's possible that it's slightly overestimated or underestimated the area between the curve and the x-axis. So to find the exact area, we're going to integrate y equals sine x with respect to x from 0 to pi. So if we write that in integral form, it's the integral of sine x dx from pi to 0. If we open up our tables, we can see that the integral of sine x is minus cos x, and so this becomes minus cos x with limits of pi and 0. We sub in the pi and the 0, and we get minus cos of pi minus cos of 0. The cos of pi is equal to minus 1, and the cos of 0 is equal to 1. And so subbing these values in here, we have minus 1 minus 1, which becomes plus 1, which is equal to 2. So we have an exact value now for the area between the curve and the x-axis, which is 2 units squared. In the final part of the question, they ask us to find the percentage error in our answer to B above. So the percentage error is going to be the error divided by the actual times 100. Our actual value for the area is 2, found by integration. Our estimated area was 1.95407 using the trapezoidal rule. And so the error is the difference between those two numbers. So if we subtract 1.95407 from 2, divided by the actual area, which is 2, and multiply by 100, we get that the error is 2.3%.